to The Deep Dive. We're the show that tries to cut through the noise and get you, well, properly informed.
That's the goal.
Today we're digging into something that's everywhere. Cell towers and mobile phones. This tech is just part of life now, but it definitely sparks some big questions.
Absolutely.
So our mission for you today is a real deep dive. We've looked at, research papers, government reports, even city FAQs, trying to get a handle on how they work, why we need them, and what the potential impacts might be.
Exactly. And there's a lot of conflicting stuff out there, so we'll try to unpack that, pull out the key facts, and give you a clear perspective without, drowning you in technical jargon.
Okay, let's jump in. First up, the basic what and why of cell towers. I mean, our phones aren't just for calls anymore, are they?
Oh, not at all. They've really become this basic communication lifeline. Think texting, email, browsing, video. It's way beyond just voice now.
Right. And the towers are the backbone for all of that. The growth in users and just the sheer amount of data we all consume means they're absolutely critical.
Totally. And structurally, what are we looking at? Usually tall structures, right? Like monopoles or maybe those latticework ones you see.
Yeah, exactly. They house the antennas sending and receiving radio frequency signals, RF signals.
And each tower creates a sort of coverage zone, a cell. That's where the name comes from, isn't it?
That's it. Your phone jumps from cell to cell as you move. Keeps the connection going.
And the height varies quite a bit, yeah, like maybe 15 meters up to, 65 meters or so? Depends on the terrain, buildings, that kind of thing.
Makes sense. So that's the basic setup, but how's the tech inside changing? Because demand just keeps going up.
It's evolving fast. The big trend is towards these denser networks, sometimes called heterogeneous networks.
So what does that mean practically?
Well, instead of just a few huge towers, you might have lots of smaller antennas, maybe on lampposts or buildings, closer to the ground, closer to users. And they often use remote radio units, RRUs, placed right near the antennas. It boosts capacity, improves coverage, and actually cuts down on cabling costs, too. It's a pretty significant shift.
Got it. So more smaller points rather than fewer big ones?
In a nutshell, yeah.
Okay, that evolution inevitably brings us to the big debate. Health impacts. Radiation.
The elephant in the room.
Both phones and towers give off electromagnetic radiation, EMR. It's a type of non-ionizing radio frequency energy.
And that non-ionizing part is key, isn't it?
It is. It means it's not like X-rays or gamma rays. It doesn't have enough energy to directly break chemical bonds or, damage DNA in the same way.
Right. That's a crucial distinction.
But still, you see reports, some studies linking this EMR to various health concerns. Things like blood cell changes, maybe sleep disruption, memory issues.
And more serious worries, too, like links to certain cancers, brain tumors, even things like miscarriage risk. Some researchers talk about potential DNA damage or stress responses at a biochemical level.
It sounds quite alarming when you list it like that.
It does. But then you have the other side. Major health organizations looking at the same data.
Exactly. And this is where it gets really complex for people trying to understand the risk. You've got major bodies, the FDA in the U.S., the FCC, CDC, the National Cancer Institute.
Big names.
Right. And they largely say there's no conclusive scientific evidence linking this RF energy to health problems.
So no smoking gun.
Pretty much. They point out that the only known biological effect of this type of RF energy is heating. Like a microwave oven, but obviously way, way lower power.
And the levels from phones and towers aren't enough to cause any significant temperature rise in the body.
That's the finding. Plus, these large international studies, like one called Interphone, looked at thousands of people.
What did they find?
They found no consistent link. Sometimes even a slightly reduced risk for certain tumors, oddly enough. They highlighted issues like potential biases in some studies that did show harm.
And the fact that cancer rates haven't really shot up globally despite billions using phones now?
That's another point they often raise. It's not just about the conflicting results, but why it's so hard to get a definitive answer. Measuring long-term, low-level exposure, isolating it from everything else in life, it's incredibly difficult.
So with all this uncertainty, what do we do? That's where the precautionary principle comes in, right?
Exactly. Better safe than sorry. Even without definitive proof of harm, some groups argue for caution.
Like using headsets or speaker phones, keeping the phone away from your head.
Yeah, simple stuff like that.
Yeah.
And also recommendations about where towers shouldn't be placed. Maybe not right next to homes, schools, hospitals.
Okay.
Just because the science isn't fully settled.
Which leads right into regulation and community control. How is this managed?
Well, there have been pushes for more transparency. Like in India, proposals for mandatory disclosure of radiation levels, the SAR value, specific absorption rate for phones, and maybe even towers.
Makes sense. People want to know.
Absolutely. And you see frequent community opposition when a new tower is proposed,
Mm.
mostly driven by these health fears.
Like in France, where some experts recommended minimum distances, maybe 100 meters, between antennas and homes.
Right. But then in the U.S., it's a bit different. Federal law can actually limit a local town's ability to reject a tower, just based on health concerns, if the tower meets FCC guidelines.
Ah, so it's complicated legally.
Very. And then there's the money angle. Private property owners, churches, schools, individuals can get rent for hosting a tower. Maybe, $800 to $2,000 a month. That can definitely influence where they end up.
Yeah, you can see how that would.
So we've talked health, regulation, but what about just finding these towers? It's not like there's a public map usually.
No, typically the carriers keep those locations under wraps, security reasons, competition.
But technology's finding ways around that now, isn't it?
Yeah, this is pretty cool. There are new machine learning methods emerging. They use crowdsourced data like signal strength measurements from people's phones and neural networks.
To basically predict where the hidden towers are?
Exactly. And apparently they're getting really good at it, even better than older methods. It's kind of like using AI to reveal this hidden infrastructure.
Pulling back the curtain, in a way.
Yeah.
Democratizing the data.
Sort of, yeah. Shifting the information balance a bit.
Okay, so we've covered a lot of ground. The absolute necessity of this tech, how it's evolving, the really tangled debate about health risks, the regulations.
That's a lot to take in.
It really is. And it leaves us with this big, unanswered question, doesn't it? We rely on these phones, this network, for almost everything now. How do you personally square that reliance with the fact that the scientific debate about safety is still ongoing?
That's the million-dollar question, isn't it? There's no easy answer.
No.
Yeah.
So maybe the final thought for you listening is this. How does understanding a bit more about both the benefits and these lingering concerns change how you think about your own phone and about this invisible network that ties our modern world together?
Something to definitely think about.